Hey guys, Joe here, and welcome to the, what is it? Is it 8th or ninth? I don't remember. Anyways, I just recorded the last video. But today, we're going to be talking about standing on our platform. Last episode, we implemented the axis-aligned bounding box collision detection to our player and a platform object we just created. So now we actually want our player to collide with the box. He does collide, as in it detects that, hey, their boxes are overlapping, but the player doesn't actually do anything when they collide. He doesn't get stopped by it. He doesn't stand on it. We want him to stand on it. Okay? So here's how we can do that. Now, all we have to do is actually modify code in our collision, right? So if we collide, we can do something. So if other that get tag that equals ignore case, and I'm going to make a collision detection for a platform. So if we collide with a platform, what do we do? Okay, so first things first, we need to know, are we above, below, left, or right? So first, right now, I'm just going to say, are we above it? All right, and we're going to walk on top of it. So if we're colliding, and if our center x is less than, is greater, actually it'll be less than, because the higher you are, the lesser you are in the y-axis. So if our y is less than their y, we're on top of them, and we should be on top of them. Okay, so what we're gonna do is we're gonna say we need to get the components. So I'm gonna get my own component. So AABB component, my component. I'm going to name this very understandably my component. It's going to be equal to this dot find component, and it's going to be platform, not platform, find component AABB, which I don't think I gave my component a tag. What is this problem? Doesn't that match? Oh, and then let's go back to my AABB component, because I didn't actually say this dot tag is equal to AABB. That'll be the name of my component. Let's go back to player, and we have a problem. We need to cast this to an AABB component once we find it, because our find component only returns component, which we should be able to find it. And I'm going to get the component of the other collider, which is I'm going to say other C. Let's call this my C and other C. I don't like typing a lot, okay? And this will be other.find component. So now we got both of our components. So if my C.get center x, center y, is less than other C.get center y, I'm on top. And we're colliding. So I want to move my player upwards so we're no longer colliding, and it looks like I'm standing on top of it. Seems simple enough. So what I want to do is say my C dot. So what I want to do is move upwards. Now I need to calculate how far do I need to move upwards. So I need to know how much are we colliding. So I'm going to say int distance. What the? Int distance is equal to the difference between how close we are and how close we should be. All right. So how close we should be is my C dot get half height plus my C dot get, and my C other C get half height. All right, and that's how far we should be minus how far we are. So minus my C dot get center y, and I'm going to actually reverse this order. My other C dot get center y minus my C dot get center y, which should give us our distance. And then I'm going to say offset y minus equal distance. Now, when you have two forms of collision detection, or multiple forms of collision detection in a game, you can run into problems. A lot of problems, because these are two different ways of detecting collision, so we're probably going to run into a lot of problems that get them communicating properly, but we should get something. Okay? We didn't get exactly what we wanted, but let's actually just print out this distance. Let's see if we're calculating this distance right. Actually, yeah, we're doing this right, but I need to say fall distance equals 0. Okay, so we're gonna run it. And we got it, but we keep falling because, well, the way we tell if we're on the ground with our current movement system is that we say we're on the ground. So we need to say ground equals true. Oh, but hold up, wait, we got a problem here. The problem is we say we're on the ground, but we're still jittering around. We don't actually say, because at the very beginning of our if statement, we say ground equals false. Because we're looking for the bottom, right? We're looking to see the ground, and we don't see the ground in our tile collision because, there's no tile below us. So we have to say, hey, guess, but we are colliding with something. So I'm going to need to put in a method here, a boolean, not a method. I'm going to put it right here with the other boolean. So private boolean colliding equals true. I mean false. Right? So colliding down here, we'll say colliding equals true. So we are colliding with something. If we're not colliding with something, then we don't want this to be called. So how can we do that? So we're updating last, and then we collide. And then the next frame is when we actually check our movement. Right? We collided, and then we're actually checking to see if we should move. Let's do, how can we make these two collision systems communicate without just completely getting rid of our tiles and going only for AABB collision? Right? Because it would be easier if we just use only one collision system. But I want to use multiple here. So I only want to move down this fall distance plus equals dt. This right here, if we're not colliding. So if not colliding, do this, right? And not ground. Right, which should be inherent. But the problem is now we go boop. We are now on top of it. But we're permanently stuck because we're always colliding. We don't have a way of turning colliding off. The only way I can think of maybe would be to say put colliding here to false, and then it'll update the component, and then physics will update, and then we'll see if we're colliding again. But we might get jitteriness. No, we're not getting jittering. Now we do for a frame enter, which is interesting that for one frame it does go inside. Which it shouldn't go inside for one frame. Because we move, right? We're inside of it. We update our component. We check our collision. We collide. We move upwards. And fall distance 0. Everything is 0. Why is it that we go inside of it for one frame? It might be a little hard to see on the video. But we do, in fact, also we don't stop colliding when we walk off. But maybe setting ground to true is a bad idea. No. For some reason now, oh, we're never adding because we're checking if we're on the ground. Maybe putting the ground here for fall distance is not needed. Maybe we don't need to fix what's not broken, right? So we fall, but we do keep spamming into there now. Oop. Oop. Huh. And if I set ground equal to true, we'll still spam into it. Okay. Actually, I think what we need here is not fall distance or ground not being true. That might be what we need. One or the other. No, it's still a bit weird. So if we're colliding, we don't want to add down. Do I have ground down here still? I do not. So if I say ground equals true, we come back up here, and we'll do an OR. Does this fix our spamming problem? Okay, he still falls, but he still spams. But hey, he's not falling into it as much. He's still falling into it. All right, we're trying to get these two systems to communicate. And that is causing problems, which I expected there to be problems. So we're colliding with it and we can't stop. Let's see here. What can we do? What can we do? We adjust ourselves, but then we have fall distance equals false here. Then we add to it. I'm going to actually move this down below it. That might fix it. The order. No, he still spams. Still adding on. Which is weird. And okay, that fixed that, but the problem is now we never leave, which is interesting. So is our ground only being set to false at the very beginning here? It is. The only time our ground is set to false is if we jump and we're on the ground. Which, actually, coming down here to collide, I'm going to say ground equals false. Alright. So now, we collide. Although I can't jump. I can't jump. Which, because our jump depends on us being on the ground. Alright. And we're on the ground here. If our fall, we only check if we're on the ground if our fall distance is greater than 0. But we're setting our fall distance to 0. So I'm going to say greater than or equal to 0. Because we still can't jump. Why can we not jump? Right? Fall distance equals jump. And ground equals false. So we jump. Ground. We have, wait, what? Where are we here? Yeah. Get rid of this. I still can't jump. And is that because I set ground equal to false down here? Which should not affect it. Why? Well, ground gets set to false, and then we come down here, but we have no detection whether or not we're on the ground before we actually try to jump. That's why. We need to move jump down past our jump detection, so our ground detection. There we go. We fall, we land. We still not getting what we want. Which I still find very interesting that it does not give us what we want. Fall distance equals 0. Sliding equals 0. Y minus equals distance. That should, in theory, work. But it's not. Which is weird. Because we're still adding on. Fall distance still gets added on. Because fall distance adds on to the fall speed. Or we're always adding on the fall distance. Whether or not we're falling. So I'm going to say we are only going to add on here if we're not colliding. And see what happens here. We're still, hang on. We're not colliding and we're not on the ground. We still fall. We still hit this. Let's say else. Still adding on to the fall distance. Fall distance equals 0. And we'll run that. And we still get the same result, which is so weird. Right? What is moving us down? Because we move down, we move up a frame, and we're no longer colliding. We then move down, and then we see that we're colliding, and then we move back up. But there's like a frame difference. If you can see that. It should be detecting in the same frame that we move down that it should move us back up. But it's not. And I find that very weird. It should always be moving us back upwards. We had it there at one point. Almost. This is the fun of debugging. Right, this distance is always the same, right? One. Okay, it's spamming 1. All right, which is true. It should only move us down about a frame, and then moves us back up. If I subtract 1 from this, it'll always be colliding. See, now we're always touching the ground. We can't jump, but it's not doing the spamming because it never moves us all the way outside of the box. But we do want it to move us all the way outside of the box. We don't want to be stuck inside the box. So now I can't jump. But we're getting close to what we want. So it moves us out, right? And that's fine. It does is that because our off position X and position Y calculated after the fact? Hang on. That's because we're calculating all the way up here. Let's move it down. We want to calculate it very last, our position. That might be causing it right there. Oh, that's very interesting. Oh, now we're getting last frame. You see our box is lagging behind. Copy, paste. I actually want to calculate this twice. Oh, I think we're getting somewhere here. We might be. We might just be getting somewhere here. Is there something I'm missing? So weird. What is... I feel like he's spamming even more now. Maybe instead of doing the movement here, because this animation stuff needs to know where he is as well. But we'll put him back. We'll put its calculation back here, but I'm going to calculate it again at the end. Okay. Still doing the animation thing. I was hoping maybe it would fix the animation. Why does he still do that? We're fixing his position, but he still falls repeatedly. That is weird. That is weird. Why does he do that? Is it really him? Yeah, the box is falling. The box is moving. It's not just him animating, spazzing out while animating real quick. This is going to require a bit of a headache. So the problem is that we're having two collision systems communicate. We have the option of removing one of the systems and not letting him collide with moving platforms and tiles, or having him remove with only platforms and have levels made from platforms and not from tiles. That's like our options here currently. Or we can keep working at this and get it to work with both. I'm going to keep working at it here. I'm not going to have you guys force you guys to watch me working on this here, so I'm going to put a cut in the video here and come back when I solve the issue. Alrighty guys, I did it. I fixed it. And I'm going to go over what I did. I didn't do much, more just playing around. So what I managed to do was, I'm not sure exactly what was different before and what was after, but I'm going to go from the top down and just explain the code. And I think I'll put this update code in the description, or not in the description, but in like a paste bin, just because I changed things off camera. So I didn't change anything with moving left and right. I did take, so the mainly is the jump and gravity where it changed. So fall distance is plus equals dt times fall distance, same thing. And we had the same for fall distance less than 0, fall distance is greater than 0. I got rid of the equals to. But the main thing I did, I put the jump at the bottom, which I did that on camera, but I put also the fall distance where we added onto our offset y at the end, okay? And then the next thing I changed was that inside of our falling, so like our fall animation, I set it back to fall distance does not equal 0, because without it, by saying ground, it just spasmed out. And I also use this opportunity to say that, oh, because we're not, fall distance doesn't equal 0, then we're on the ground. Which actually, that might mean we can jump at the very top of our jump. Now let me make sure I did not actually make a bug. So instead of key down, I'm going to say key. We shouldn't get a double jump at the top of our jump. No, because it's still checking for the ground. So no, I didn't put in a bug by doing that. So, there we go. And then we go down. The main thing that changed it, that fixed it, was instead of just moving my offset y up, I also needed to move my position y up. And that is the main thing that really fixed it. So it wasn't that difficult, but it required some toiling around, and I don't think you guys wanted to sit there and watch me do that for however long it took me. I think it took me about 10 minutes of just messing around, moving things around to figure out what worked. And so now, when you go in game, the player jumps on it. Don't mind the spasming component box. I did fix that, but there's it's not really required that you do that. And the fix that I need to do is set the center Y to my C that get center Y minus distance. So just move the actual bounding box up with it, which fixes the spasming box. But yeah, so now we actually have a box that we can stand on. When we jump up through it, we do kind of just teleport up, which, I mean, we don't want a player to get stuck inside of a box, but if you were to say make a box where you wanted it so like the player can jump through it, a simple way that you could do that is to say and fall distance is greater than 0. So it'll only do this check if we're falling downwards. So if we come in here and we jump, we can jump through it and it land on top, which is a nice little handy thing. So yeah, now we have tiles and platforms. We don't have side collision and bottom collision yet, just because the video is getting long. I had to fix that. So I think we'll add that in the next part of this tutorial, so in the next episode. So yeah guys, comment, rate, subscribe. Make sure you check out, I'm going to put the code for the player just in a paste bin, just because of, it might be hard to follow in the video, and I understand that. So yeah guys, comment, rate, subscribe, and thanks for watching.